Here is another example of a OpAmp circuit. What is the input impedance as seen by the source VA of the following circuit? Okay, so input impedance is let's call that Zin, is following the standard Ohm's law. This would be Vin. In this case, they called the input voltage VA, so let's follow the standard and use VA to not get confused. So that would be VA, V input over the input current, right? Because they say here seen by the source, so the input current. So we know what VA is. It's already given us 15, so we have 15 over IN. So the only thing we need to find in this particular short problem is IN, the input current. Now we can use KCL. Okay, so let's call, before we even go there, not necessary actually. So let's call this IN. So if we don't need to, but I just want to show you one thing. If we were to use it, remember that for an OpAmp, no current will flow through. Remember, so no current flowing flows through. And then the other one is that your voltage over here, V2, is equal to your voltage V1. So in this case, V2 is equal to V1. What's V1? That's 5. That's VB. It's 5. Is equal to VB, and that's 5. Okay, so we don't even need to use KCL here because you can already see that IN is equal to the voltage, the potential difference between this, because it's across the resistor 5. So you would have VA minus V2, but V2 was 5 volts. So you would have VA, let me just write it down, VA minus V2 over 5 kilo ohms. So in this case, VA is 15 minus V2, which was 5. I'm dealing with volts. Okay, so 5 kilo times 10 to the power 3. So you got 10 over 5. So that would be 10 milliamps. 2 milliamps, excuse me. Okay, so we can go back here and calculate our Zin. We have 15 over 2, 15 volt over 2 milliamps, so 10 times 10 to the power minus 3, and that would be 7.5 kilo ohms. And that's pretty much it. Very simple. Okay, so hopefully you get a feel of the OpAmps. If you practice a little bit more, then you could see it, because it's really simple, you know. 2 conditions: current doesn't flow through, and then V2, the legs, the voltage at the negative leg is equal to the voltage at the positive leg. Always start from there. Okay, and that's pretty much it for this problem. See you.